Good morning, guys. Welcome again to my session with Mr. M. And today we are doing Euclidean geometry, grade 12, and we are going to deal with circles. So I wanted to take note of 4 things when we are dealing with circles. And number 1, the line drawn from the center of the circle perpendicular to the chord, it bisects the chord. Number 2, proof number 2, which you must know, is the angle subtended by an arc at the center of the circle is double the size the angle subtended by the same arc at the circumference of the circle. Number 3, the opposite angles of a circular quadrilateral, they are supplementary, which means when you add them together, they must always give you 180 degrees. Number 4, the last one, is the angle between the tangent and the chord. They are equal to the angle in the alternate segment. So I have a question here right in front of me, which is saying we must prove now, giving reasons, 3 angles that are equal to x. So we are given this kind of a diagram right here. At the center we see that there is a 2x right there, and now it's saying to us we must give 3 reasons which are giving us they are equal to, in fact, equal to x. Number 1, we must take note of what we are given on this diagram. Number 1, there's our first hint. There's our first hint. Our first hint is telling us that these lines are parallel, which means they are equal. Now, whatever is between the lines that are parallel, we can work something out there. So we are looking for angles that are equal to x. The first thing that we can look at is where x is, and we only see it right at the angle that is at the center, that is 2x. Now we know very well the rule that the angle subtended by an arc at the center of the circle is double the size the angle at the circumference of the circle, which means angle G is equal to x. We are going to write that one, angle G is equal to x, and the reason angle at center is twice the angle at the circumference. So we have given our first reason. Number 2, what else can we see here? Number 2, what else can we see here? I can see that this angle is equal to that angle right there. Because these lines are parallel, I see an alternate angle. And alternate angles, they are equal, which means now angle H1 is equal to x also. Now our reason is this, that they are alternate angles. Do you see that now? So we have proven 2. 1, the angle that is double the size. Number 2, alternate angles. Number 3, what else can we find here? I already see everything, because now we already know the rules of a circle when it comes to Euclidean geometry. Now, if you look at these lines, you are going to see that this angle right here is equal to this angle right here, according to the rule of the tangent and the chord, according to the tan-chord theorem, which is stating that the angle between the tangent and the chord is equal to the alternate angle, the angle in the alternate segment. So this angle right here is equal to the angle which is GJH. Now we are going to write that one down, that angle GJH is equal to also x, because H1 is equal to x. What is our reason? Our reason, this angle is a tan-chord theorem. Tan-chord theorem. So you already have a lot of marks in your packet with only those 3 explained angles, giving them their identity. Today, that is all for grade 12. If you want more on Euclidean geometry, you know what to do. You can just press that book button and I'll be there to assist you. From me, Mr. M, have a wonderful day. Bye-bye. God bless you.